Hey guys, so welcome to our last session of the semester. This is a final exam review session, and this will be my last section for this course as a SI. Um, so I think in the class he went over the topics that he will put on the exam. So he said there'll be 5 multiple choice and 3 free response problems. He didn't really specify what type of multiple choice problem that will be on the exam, but he did mention that it'll be everything that's from frames to chapter 10, which is century stuff that you guys did. So I just guess that that's based on my experience. I guess that that'll be 5 types of multiple choice question that he'll put on exam. So most likely, 90% of the time he will put like a fluid pressure exam. And then for those type of problem, it usually just asks you to find what's the maximum force or what's the fluid pressure of a given graph. And then this is the formula you're gonna apply. So P right here represents the fluid pressure. The rho right here, it represents the density of the liquid. It can either be water or mercury or oils, any kind of fluid, any kind of liquid. So that represents that, and that value usually is given. And we know that for water, rho is always 1,000 kilogram per meter cube, right? Then the G right here represents the gravity constant. Z right here represents the depth, and then gamma is just equal to rho G. Okay, we know that. And then W right here represents the weight. So after you determine what the pressure is, you're able to determine the weight. So weight, you just taking the pressure multiplied by this width right here. It will usually give me, if not, you can tell by the graph. Second one problem he will put on there is probably revolutional theorems. That's probably the last thing that gets went over. And here's the formula. Next thing will probably be a century problems. We know that for century problem, is if it's a big century problem, then it's always good that you construct a table. You're having areas, X bars and Y bars all laid up. If possible, you might even do like a moment of inertia in a multiple choice problem. But I think that he would put that in the free response instead. So for a multiple choice century problem, you I won't say like don't expect there will be to do moment of inertia, but like heads up with that. Okay, and here's the formula. Next thing will probably be like a dry friction problem. And for that, you have to consider tipping versus slipping. So we always consider slipping first. If that passes check, then you don't have to do the tipping portion, but like you always have to consider slipping first. By slipping first, I mean that you have to assume that the force is equal to the coefficient of the dry friction multiplied by the normal force. And then next type of friction problem is probably put in there is a belt friction problem. And here's the formula for that. And then so T2 is always the one that is greater than T1. Like if the force is going into the T2 direction, then that means that T2 is greater than T1. But if force is going into the T1 direction, that means that T1 is greater than T2. And the belt friction, beta is in radians. So if you get like an angle, you have to multiply that by pi over 180 to get that in to get the angle form into radian form. Okay. Next thing, are you guys familiar with that? Trusses, Medfield sections, probably he won't put any Medfield joints problem on there. It's too long. Medfield joints, probably. We know that for that. 3 equations to use summation of force in the X, in the Y, and also moment. Okay. And then rigid body equilibrium. This is a pretty broad topic. So frame can be a rigid body trust can also be a rigid body equilibrium, to be honest. So this is pretty broad topic. So by rigid body equilibrium, I mean that anything that you have to do with this three formula right here. That's my own concept of what rigid body equilibrium type of problem is. Okay, and three types of free response problem, like he mentioned, moment of inertia. You have to do the centroid part first, and then from that you can find the moment of inertia. I will show you guys all the equations later on in those problems. And then frictions is related to the things I said right there. And next thing, the frames. So frames, I consider that as a rigid body equilibrium problem. It really is just apply that three formulas, to be honest. Okay, so that's a quick little one over of the topics that he will put on the final. And right now, I will run you guys through some example problems. Okay, so problem one says, determine the moment of inertia of the shaded area shown with respect to x and y axis. Okay, then it suggests that we need to consider the entire rectangle and the two color rectangle. What does that mean? That means that when we construct that table, we want to consider this entire rectangle as one piece, and then we consider this two color as two separate pieces. Okay, I'm gonna lay the table out. Okay, so right here is a segment. The other one's the area. That'll be inch square. Then that's the centroid of each segment. And then that's the moment of inertia of that one segment. And then that's the moment of inertia for the entire segment, like when you combine the previous three segments. Okay, let's see. So like I said, we consider three segments. So I'll say this entire thing as one segment, and then this will be segment 2 and segment 3. Oh, it'll be better if I just put segment 1 right here. Okay, and then we label them 1, 2. Okay. So for segment 1, what's the area? Okay, so we can see the segment 1, this entire thing. So the width will probably be 2 plus 2 plus 1/2 plus 1/2, so that's 5 inch width. And then for the length, that's 2 plus 1 plus 1 plus 1 plus 1. That's going to be 6 inch. Okay, so the area is probably just 5 multiplied by 6, which is 30. Okay, and then what about the centroid? Well, like I said, this thing essentially is about the origin, so it doesn't have any centroid. So for this big segment right here is 0. That's in the x direction. Okay, same as in the y direction as well, because this is in the origin. And then ix bar and iy bar, what formula do I use? Well, we know that this is a rectangle. So in the exam, he will provide you a moment of inertia equation sheet. You are able to determine the moment of inertia for different type of shapes. So for a rectangle shape, ix is always that's the base times the height. Base times height cube over 12. And then for y is the reverse. So height multiplied by base cube over 12. Okay, so we're going to use this formula. So for segment 1, B, that would be 5, and then the height would be 6. So 5 multiplied by 6 over 12. Don't forget that cube is often of times students forget to cube it, or student just square it. So that's a very common mistake. So put that in the calculator. We got 90 inch 4 for I bar x, and then for I bar y, it's the reverse. So 6 multiplied 5 cubed over 12. That's 62.5. Okay. And then don't worry about these two right now. We're gonna do them after we fill out other blank spot of this table. Okay. So for segment 2, the area. Okay, we can see that segment 2 area is 4. That's the base, and the height is 2. So 4 multiplied by 2, that's 8. And then the centroid in the x direction. So we can see that 2 and 1, 1, 2, and 3, those 3 segments, they are at the same, I should say, they are rotated in the same y-axis. So that means that they don't have any direction distance, so they don't have any x direction centroid. So for them, their x centroid will always be 0, but different for the y, because we can see that the centroid for segment 2 is right here. And then we have to consider that with respect to this origin. Okay, so what's this distance right here? This distance, but this distance is, this is 1 inch right here, and this entire thing is 2 inch. So half of this 2 inch is 1 inch, right? So this thing will be 2 inch. Okay. Let me write 1 plus 1 equals 2, so you guys can see it better. And then for I x bar and y bar, do the same thing. So for I x bar, be 4 multiplied by 2 cube over 12, and you get 2.67. And then for I y bar, that's 2 multiplied by 4 cube over 12, and that will be equal to 10.67. Okay. And then for segment 3, we know that the height is 1, the base is also 4. So 4 multiplied by 1, that's 4. And like I said, it doesn't have any x centroid, but it does have a y centroid. So its y centroid is the centroid of this segment right here to the origin, which is, this is 1 divided by, so this distance right here is 1/2. Okay, and then you have to plus this 1. So this thing is a 1 plus 0.5, which is 1/2, so 1.5 plus this thing. So by the centroid, what I mean is that it's always from the centroid of this segment to the origin. Okay. And we can see that for 1, it doesn't have any, because its centroid is at the origin. So it doesn't have any x bar or y bar, but for 2, it's different. For in the y direction, you can see that they do have a distance from their centroid to the origin, but in the x system, they don't. Okay. And then for I x bar, so that would be 4 multiplied by 1 cube over 12, and we get 0.33. And then for I y bar, so it's 1 multiplied by 4 cube over 12, that's 5.33. Okay. And then next thing we'll have to do that is for these two, we have to apply the formulas. Ix is equal to Ix bar plus the area multiplied by the perpendicular distance with respect to the x-axis, which is will be dy squared. Okay, and then for y, it'll be the opposite. So that's the formula you have to use to for the dy. And then since the question asking to determine the moment of inertia for the shaded area, so that means that right now we have to determine those two moments of inertia. So very likely we're going to get a very big number for segment 1, and then we subtract segment 2 and 3 from 1 because segment 2 and 3 are shaded. Okay. Oh, my bad. My bad. Let me back up. So segment 1 is shaded, but segment 2 and 3 are empty. So when we get a very big number for segment 1, we have to subtract segment 3 from 1. Okay. So let's do a solve. For segment 1, so Ix equals Ix bar, which is 90, plus area, which is 30, and then plus the dy and dx. Let me explain to you guys what dy and dx is. Dy and dx is different than x bars and y bar. Time you might see they have the same value, but their concepts different. So x bar and y bar, that's the centroid. That's from the centroid of the segment to the origin. Okay, but the dy and dx, that's from the centroid of the segment to the centroid of where x and y is. Okay. All right. So for that, since segment 1, it doesn't have any centroid, and then that means that it's going to be 0. Okay. So Ix will be just 90 henceforth. And then for Iy, that's going to be 62.4 plus area 30, but also as well, it doesn't have any perpendicular distance in the y, so 0. So that would be 62.4 inch to the fourth. Okay, so that's for segment 1. So now, let me fill that in. So 90, 63.4. And then for segment 2, so Ix will be equal to 2.67 plus the area, which is A, and then multiply by dy, and then you have to square that. And then we can see that in this example, dy is equal to y bar. That's because how this thing is oriented. But if you were to shift this x and y axis to the left or to the right, it will change. Okay, so Ix, that's 2.67 plus A, and then multiplied by the centroid 2 square, and you're gonna get 34.67 henceforth. And then for Iy, that would be 10.67 plus the area. But it doesn't have any distance along the x direction, so it'll be 0. And then we're gonna get 10.67 henceforth. And then for segment 3, Ix will be equal to 0.33 plus area 4 multiplied by the distance along the y, so that will be the y bar, so 1.5. That will be equal to 9.33 henceforth. And then for Iy, that would be 5.33 plus the area multiplied by, oh, that's going to be multiplied by 0 squared. We're going to get 5.33 henceforth. Okay, let me string down this table. Okay, next thing we have to do is that we have to determine total moment of inertia. So like I said, we have to subtract moment of inertia of 2 and 3 from 1. So Ix will be equal to Ix1 minus Ix2 minus Ix3, and same for the y. So Ix will be equal to 90 minus 34.67 minus 9.33. That's because segment 2 and 3, they're empty. So originally it doesn't have any, like originally that spot right there, that space right there is an empty space, but we just imagine they are there so that we don't have to break this thing into like different segment, because if we don't do that, then this will be a segment. This will be a segment, right? And you're gonna get Ix equal to 46" fourth. Same thing for Iy, and then for Iy, so 62.4 minus 10.67 minus 5.33. I'm gonna get 46.5" fourth. Okay, all right, guys. So that's all for problem number 1. I'll see you guys in problem number 2.